This topic will explain chemical bonding, and under that topic we will be discussing ionic bonding only. Let's start it. As we see periodic table in front of us, and we see elements arranged in the increasing order of their atomic number, and we see on the left hand side we have metals, and on the right hand side we have non-metals. Metals have a greater tendency to lose electron. So in order to gain the electronic configuration of noble gases, as noble gases are the most stable elements in the periodic table, so in order to gain the electronic configuration of noble gases, metals lose their valence shell electron. Valence shell electrons are those electrons which are present in the outermost shell of an atom. And non-metals have a greater tendency to gain electron to complete their outermost shell electronic configuration. And atoms have many different ways by which they can maintain or attain the electronic configuration of noble gases, and some of the examples are ionic bonding, covalent bonding, and metallic bonding. But today we'll discuss only ionic bonding in this video. I will post a separate video for explanation of covalent bonding. So let's discuss the example of lithium fluoride. As we see that lithium have an atomic number of 3 and atomic mass of 7. But we write the electronic structure on the basis of atomic number, because in a neutral atom the atomic number is always equal to the number of electrons. So if lithium is having the atomic number of 3, that means it is having 3 electrons. Atomic number is actually the number of proton, but as a neutral atom is having equal number of proton and electrons, so 3 is representing its proton number, which is equal to electron number. So it is having ultimately 3 electrons in the atomic neutral atom. And the arrangement would be 2 in the first shell and 1 in the last shell. But that is not a stable electronic configuration, because to have a stable electronic configuration, as I have already shared, that metals lose electron and non-metals gain electron. So in case of lithium, as it is having 1 electron in the outermost shell, it has a greater tendency to lose its electron to the non-metals. And metals of group 1 will have a tendency, group 1, 2 and 3 metals have a greater tendency to form or to transfer the electron to the non-metals of group 5, 6 and 7. Here we are discussing the example of lithium with fluorine. So lithium belongs to the first group, so must have 1 electron in the outermost shell, and fluorine belongs to the 7th group, so fluorine is having 7 electron in the outermost shell, as you can see here. The last shell of lithium ion is not shown because it has lost its electron to fluorine. Now fluorine is a ion and it is called as a fluoride ion. It is not fluorine anymore. So it become a fluoride ion as soon as it gains an electron from lithium atom and has a overall charge of -1. As the opposite charges attract each other, so electrostatic force of attraction develops between lithium and fluorine and an ionic bond is formed. So this bond, which is formed by the complete transfer of electron from a metal to a non-metal, is called as ionic bond. So number of electron in this example, we see the number of lost electron and gained electron are equal. Further down in the lecture we will be discussing those examples where we will be discussing and looking at the example where the number of lost and gained electrons are not equal. So how we are going to represent them in a dot and cross form. We will see down in to the end of the video. But for now, lithium fluoride is formed when lithium atom is losing 1 electron and forming a cation, because cations are positively charged ions and forms when an atom loses electron. And fluoride ion is an anion, and anions are a negatively charged ions. As you can see here, there is a negative charge on fluoride ion. And anions are formed when an atom gain electron. Let's discuss another example, the formation of magnesium oxide. Magnesium belongs to the 2nd group and it is having us 2 electrons in the outermost shell, which it is going to lose to oxygen atom. Oxygen belongs to the 6th group, so it is having 6 electrons in the outermost shell. So both the atoms have a greater tendency to attain the electronic configuration by the loss and gain of electron. As magnesium is a metal, so it is going to lose electron, and oxygen, which is a non-metal, has a tendency to gain electron. So magnesium will lose its 2 electron in the outermost shell. So that shell we are not going to draw while we are forming a magnesium ion. So the valence shell will not be drawn because the 2 electrons have been transferred or lost. So that shell is completely finished, that is vanished. So now the valence shell is the one which is the inner shell, and it is having now 8 electrons, as you can see on the screen. There are only 2 shells of magnesium ion shown. First shell is having 2 and the second is having 8 electrons, and there was one shell in the atomic structure where there were 2 electrons. As magnesium it should have 8 electron in the third shell, so it is very difficult, energetically not possible for magnesium atom to gain 6 more electrons to complete its octet. So it is easier for it to lose those 2 electrons in the valence shell. So it is going to lose those electrons and form a magnesium +2 ion, which are being gained by the oxygen atom. So oxide ion is formed with a -2 electron. Now the valence shell is having 8 electron. You see there are 6 electrons shown as crosses and 2 electrons are shown as dot. These 2 dots are actually the 2 electrons which the oxygen atom has gained from magnesium atom to form an oxide ion. Again, in this example we have equal number of electron lost and gain. So I hope you understand how you can draw the dot and cross diagram for the formation of magnesium oxide. Alright, let's discuss another example where we are forming the aluminium nitride, where aluminium atom belongs to the third group having a valency of +3 and nitrogen atom belongs to the fifth group, so must have a 5 electron in the outermost shell. It needs 3 more, so it will gain 3 electron and have a charge of -3. So these are the dot and cross diagrams for the formation of this ionic compound, and here again the number of lost electron is equal to the number of gain electron. Okay, now let's see how the strength of the ionic bond varies, or on what factors does it depend. The strength of the ionic bond depends upon the charge on the ion. The greater the charge, the stronger is the ionic bond. And there is one more factor that affects the strength of the ionic bond, and that is for A-level students, that where they see compare the size of the ions. The smaller the ion, the closely they are packed, and stronger is the ionic bond because they have strong electrostatic force of attraction between the ions. So the strength of the ionic bond depends upon 2 factors: the charge on the ion and the size of the ion. Now let's see an example of formation of ionic compound where the number of lost electron is not equal to the number of gain electron. The atoms are 1:1. So in that case, the number of gain and lost electrons are not equal. But when the number of the atoms differ, then this is how we balance the number of lost and gain electron. Some of students might not be understanding it, but further when I'm going to explain, they will understand. So keep watching. So magnesium atom is having a gain electronic configuration of 2, 8 and 2. The last 2 electron in the valence shell are being lost, and nitrogen, which is belonging to the fifth group, have 5 electrons in the outermost shell, so it needs 3 more. So what is going to happen when one magnesium atom loses 2 and one nitrogen atom needs 3? So we are going to multiply both the numbers with the whole number that makes a equal number of atoms on both sides. Like if we are having +2 electrons lost, like 2 electrons lost by one magnesium atom, so we need 3 magnesium atom to lose 6 electrons. That is a whole number, right? And one nitrogen atom needs 3 electrons, so we need 2 nitrogen atoms that can gain 6 electrons. So 3 magnesium atoms will lose 6 electrons to 2 nitrogen atoms. So the number of the charges on both of them are equal, and this is how we work on their ionic formula, magnesium 3 atoms and nitrogen 2 atoms. This is how it can be justified. The formula is justified, and this is how you understand that why magnesium is 3 in this case and nitrogen is 2, because 3 magnesium atoms are losing 6 electrons which are gained by 2 nitrogen atoms which are gaining 6 electrons. So it is not magnesium nitrogen, it is magnesium nitride. The name is magnesium nitride now. Alright, one more example is aluminium fluoride. It is shown on the screen that aluminium loses 3 electron, 1 fluorine needs 1 electron. So of course we need 3 fluorine atoms to equal the or to accommodate those 3 electrons lost by aluminium, and aluminium atom come closer to fluorine atom. So hope you understand this. In case you don't, please write in the comment section. I will make another video to explain how the number of electron lost and gain could be made equal by multiplying it with a whole number. Alright, so there is a homework for you guys. There are few examples given, not example, there's few equations given on this screen you see. So you try the dot and cross diagram for these structures and let me know that you can draw the dot and cross diagram for these structures or not. You can write in the comment section if any of the structures you are not able to draw, so I will draw it for you guys. Alright, there is one more example, aluminium oxide. Shown on the screen, you can easily see 1 aluminium atom loses 3 electrons, so 2 loses 6, so 1 oxygen atom gains 2 electrons, so having a charge of -2. So when 2 aluminium atoms are losing 6 electrons, they will be accommodated by the 3 oxygen atoms, because 1 oxygen atom needs 2 electrons, so automatically 3 oxygen atom will need 6 electrons, so number of electrons are balanced, and this is how the ionic formula is formed. Yeah. Alright, so I think that's all for this video, and for the physical properties of ionic compounds I'm going to make a second video. Thank you so much for now. I'll catch you in the next video. Thank you. God bless. Allah Hafiz.